Okay, good morning students, and today we'll see exercise number 10.8, mechanical properties of fluids. Read the question first, what he has given. A hydraulic lift means a hydraulic automobile. A lift is designed to lift a car with a maximum mass that is 3000 kg. The cross-sectional area of a piston carrying the load is 425 centimeter square. What maximum pressure would be the smaller piston have to be bear? And the question is the applications of a Pascal law. And the diagram, for convenient purpose, I have drawn the diagram. That is a hydraulic lift, and this is a smaller piston and this is a bigger piston, and we have to apply a force on a smaller piston, and on the area of this piston, after applying force, how much pressure that would be the smaller piston have to be bear. That's what you need to find out. After applying force on the smaller piston, this piston exert a pressure on the liquid here, and according to definition of the Pascal law, the pressure exerting in all the directions equally distributed, and this pressure is equally distributed in this direction also, and after here the pressure is transmitting in all the direction equally. Finally it is applying on the bigger piston in upward direction. If you apply force on the smaller piston in downward direction, external force, it is exerting a pressure in the liquid in downward direction. That transmitting pressure in the liquid in all the direction is same, that is according to Pascal law. After that the pressure is exerting equally in all the direction, and finally it is exerting on a bigger piston. And after the pressure exerting on this bigger piston, and this bigger piston is moving in upward direction, as a result this heavy object is lifting off. By using a smaller force, we can able to lift a bigger object. By using a smaller force, we can able to apply we can able to lift a big object. This is the application of Pascal law. A hydraulic automobile lift. Hydraulic means this is the lift made up of, that is a liquid. Hydraulic in the sense the liquid here inside the cylinder liquid is there, and it is designed to lift a car. And it is designed to lift a car with the maximum mass is equal to 3000 kg. And this piston and this hydraulic lift is designed, it is having a capacity. How much capacity it is having? A maximum mass has to be lifting by using this one, maximum 3000 kg. Maximum 3000 kg mass anna lift maduvanta capacity idu kada. Then the cross sectional area of piston carrying the load is, means its area he has given, that is 425 centimeter square, and the piston which is lifting the object, its cross sectional area he is given, that is 425 centimeter square. What is that one? That is length into breadth. Length into breadth, that is 425 centimeter square he has given, that is for second piston. Cross sectional area for second piston. And what maximum pressure would be the smaller piston have to be bear? The maximum capacity of the bigger piston, how much maximum mass it is able to lift? That is 3000 kg. Second piston having the capacity to lift a maximum mass, that is 3000 kg. In order to lift 3000 kg of mass by the second piston, and how much will be the pressure you can apply on the first piston? ಇದು 3000 kg ಮಾಸ್ ಅನ್ನ ಲಿಫ್ಟ್ ಮಾಡಬೇಕಂದ್ರೆ ನೀವು ಎಷ್ಟು ಪ್ರೆಷರ್ ಅನ್ನ ಈ ಪಿಸ್ಟನ್ ಮೇಲೆ ಡೌನ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಒಳಗಡೆ ಅಪ್ಲೈ ಮಾಡಬೇಕು? That what you need to find out. And the direct formula, that is pressure is equal to force per unit area. And the force, that is he has given, force can be written as mass into acceleration due to gravity and area, as it is he have to write. And the total, how much a maximum mass that the second piston has to be lift, it is having the capacity to lift a maximum mass, that is equal to 3000. kg he has given here, and take the value, and g as you know very well, you can take 9.81 meter per second square, and area he has given 425 centimeter square. This is the cross sectional area of second piston, and that is 425 centimeter square as he has given, and take the centimeter square in terms of a meter square, that is therefore 425 centimeter square can be written as 425 into 10 to the power of minus 2 meter. Now centimeter is getting converted into meter, but I want centimeter square into meter square. Therefore, if you want meter square, and take the one more square, that is 425 into 10 to the power of 2 into 2 minus 4 meter square. And here substitute 3000 into 10 to the power of into 9.81 divided by 425 into 10 to the power of minus 4 meter square, and calculate the answer. The pressure that will be, that is 6.59, check the answer, 6.95 into 10 to the power of 5 Pascal. It means that in order to lift a 3000 kg of mass by the second piston, how much pressure that you need to apply on the first piston? That is 6.95 into 10 to the power of 5 Pascal. If you apply this much of pressure on the first piston, then the pressure is exerting in all the direction equally, and finally this second piston able to lift how much mass? 3000 kg. ಈ ಸೆಕೆಂಡ್ ಪಿಸ್ಟನ್ ದಿಂದ 3000 kg ಮಾಸ್ ಅನ್ನು ನೀವು ಲಿಫ್ಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಈ ಫಸ್ಟ್ ಪಿಸ್ಟನ್ ಅದ ಮೇಲೆ ಪ್ರೆಷರ್ ಎಷ್ಟು ಅಪ್ಲೈ ಮಾಡಬೇಕಾ? 6.95 into 10 to the power of 5 Pascal. And please note down this one. And go to exercise number 10.9, mechanical properties of fluids. Read the question first what he has given. A U-shaped tube contains, that is U-shaped tube is there, it contains water and methylated spirit. As you are observing in the diagram, this is a U-shaped tube is there. One side it contains, this is a water, and that side it contains a methylated spirit. And next, separated by mercury. This water and methylated spirit both are separated by using another high denser liquid, that is a mercury. Means this side, in this arm this is a water, and this arm this is a spirit. The water and spirit are getting separated by a mercury in the here tube. The mercury is there, this mercury separated water at one end and spirit at another end. The mercury in the two arms are in the level with a 10 centimeter water in one end and 12.5 centimeter with the spirit in other end. What is the specific gravity of the spirit? And what he has given? The mercury in the two arms in level with, it means that this is the water column is 10 centimeter he has given in the arm left side, and at the right side, and this spirit of a column of length is equal to 12.5 centimeter, and this is a spirit column length 12.5 centimeter, and this water column length is, that is 10 centimeter, and the water and spirit both are getting separated by another dense liquid that is called as a mercury. Then what he has asked here, you need to find out what is the specific gravity of methylated spirit. What is the specific gravity of methylated spirit? In the sense, by using this diagram, you need to find out what is the specific gravity of the spirit. The another name of, as you know very well, getting, and I taught, the specific gravity of any substance can be, we are using another word that is called as a relative density. Relative density and specific gravity both are same. And relative density in the sense that also I have discussed, that is what do you mean by a specific gravity or a relative density? That is the ratio of a density of any substance divided by a density of water at 4 degree Celsius. A specific gravity or relative density formula, as you know very well. What is a relative density? That is just a comparison of density of any two liquids. Always the density of any liquid we are going to compare with a density of water, that too at 4 degrees Celsius. And here first you need to find out, let us take this as a A point, let us take this as a A point, and let us take it as a B point. And on the A point the pressure is exerting by the water column, and on the B point the pressure is exerted by the methylated spirit. Let us take the PA is solution, the PA is the pressure, the PA is the pressure on A point by a water column. This is equal to a PB. What is PB? The pressure on a B point by the methylated spirit. And PA is the pressure at this point and PB is the pressure at this point. The pressure on A point is exerted by the water and the pressure at this point is exerted by the spirit. But both the pressure at this point and pressure at this point is exactly same. Why? Because I discussed in the theory class, because the A point is exactly in a level with the B point. The A point and B point both are at the same level inside 2 ohms of the tube. That's why the pressure on A point is exactly equal to the pressure on B point. And therefore, how to find out the pressure on A point by the water column? That is rho G H. Therefore, the density of water I am taking it as a rho 1 and G is constant for both the side, and H1 is the height of column of the water in the left arm, that is H1. This is equal to, how to find out the pressure on the B point by the spirit column? That is rho G H2. What is rho? I am taking it as rho 2 because this is a density of spirit and G on both the side is same. And what is H2? H2 is the column of, the height of column of spirit. Therefore, on both the side G is common. Therefore, G and G getting cancelled, and rho 1 into H1 divided by, that is H2 is equal to rho 2. Rho 2 you need to find out because the whose here instead of water and spirit, whose specific gravity we have to find out? Spirit specific gravity we have to find out. First you need to find out what is the density of that spirit. If you got the density of a spirit, it is easy to find out specific gravity or relative density and substitute all the value. This is water density, this is spirit density. Water density, that is standard, you know very well. The density of water at 4 degrees Celsius, that is 1000. That is 1000 kg per meter cube, and into H1 he has given, that is 10 centimeter, that is 10 centimeter, and divided by H2 he has given, that is H2 is equal to 12.5 centimeter, that is 12.5 centimeter, and this is equal to rho 2. And if you find out, rho 2 is equal to 0.8 into 10 to the power of 3 kg per meter cube, and this is a density of a spirit. And what you need to find out? Specific gravity of spirit. Specific gravity or relative density, both are same. Specific gravity or relative density, both are same. There has been a theoretical formula in order to find out this one, that is density of any substance, density of any substance divided by a density of water at 4 degrees Celsius. I have discussed in the theory, density of water at 4 degrees Celsius, at 4 degree Celsius. Whatever it is the density of liquid, whatever it is the liquid, whose density always we are going to compare with a density of the water, that too a drastic condition as a 4 degrees Celsius. Why? Because why we are taking a standard temperature? Because we have to take the density of the water always at 4 degrees Celsius, because if you increase the temperature, the density of water goes on changes, or if you decrease the temperature also, its density goes on decreases. That's why at 4 degree a standard temperature the density or pressure of the liquid never changes. That's why we have taken standard as a H2O. ಯಾವುದೋ ಒಂದು ಲಿಕ್ವಿಡ್ ಡೆನ್ಸಿಟಿನ ರಿಲೇಟಿವ್ ಡೆನ್ಸಿಟಿನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾದಾಗ ವಾಟರ್ಗಿನ ಕಂಪೇರ್ ಮಾಡ್ತಾರೆ, ಯಾಕಂದರೆ ಎಲ್ಲ ಪ್ರೆಷರ್ ಕಂಡೀಷನ್ ಒಳಗಡೆ ಆಲ್ಮೋಸ್ಟ್ ಇದರ ಡೆನ್ಸಿಟಿ ಸೇಮ್ ಇರ್ತದೆ. Therefore, the relative density of this spirit, the relative density of a substance as a spirit now, the relative density of spirit is equal to 0.8 into 10 to the power of 3 kg per meter cube and divided by, and that is 1 into 10 to the power of 3 kg per meter cube. This is the density of water, means 1000. I have written in terms of scientific notation, and unit getting cancelled and power getting cancelled, and the relative density of that of the spirit is 0.8. And don't write any more unit here, because the kg per meter cube and the kg per meter cube getting cancelled, and this is a unitless quantity, a relative density or a specific gravity, both are same. And the relative density or specific gravity of that of the methylated spirit, that comes to be 0.8. And note down. And go to next question, that is mechanical properties of fluids 10.10. Read the question first what he has given. In the previous problem, that 10.9 already I have discussed, and the problem 10.10 is exactly based on that 10.9 problem, that what I had discussed earlier problem, and on that he has given another one with the same diagram. You can consider for this one. Read the question. In the previous problem, means 10.9, you can apply the same diagram for this also. If 15 centimeter of water and the methylated spirit is further poured into the respective arms, you know very well already, this is a mercury, this is a water, and this is a spirit. The length of the water column is 10 centimeter and the spirit column is 12.5 centimeter, and both the liquids are getting separated by a mercury. And in this problem, what he is giving here, then water and methylated spirit are further poured into the tube, respective arms of the tube. That is what you need to do here. You again further add water with how much length extra? 10 centimeter. Already 10 is there. Again you need to pour the water with how much extra length? That is 15. And again spirit same 15 centimeter. Again you need to add the spirit, methylated spirit. Before adding, the length of the column is 12.5. After adding, then the spirit level that is increases. The spirit level that is increases, that is extra length, it becomes 15 centimeter. And this is 15 centimeter. And here also this is again 15 centimeter. Again 15 centimeter water you can add here. This is again 15 centimeter and 15 centimeter. Now adding the water and methylated spirit with the respective arms, the total length in the left column of the water, it becomes 10 plus 15, 25 centimeter, and that of the methylated spirit becomes 12 plus 15, 27.5 centimeter. And here this is 25 and this is 27.5 centimeter. And here, because of this variation, there has been a difference in the levels of mercury. And here this mercury column is decreases, and this side somewhat it is rising. This is falling of the mercury, and in this arm this is rising to a certain length. It means that after adding the mercury present here is somewhat decreases and the mercury here is rises. It means that you are getting the difference in the levels of mercury. Therefore, what you need to find out here, what is the difference in the level of the mercury? After adding this extra water into the arm and extra spirit into this arm, what you are going to observe? You are going to observe the difference in the levels of mercury, rising the level here of the mercury and falling of the mercury here, and the level of the mercury is not become same. Therefore, there has been, you are observing, there is a difference in the level of the mercury on both the arms. That difference you need to find out. It means that somewhat varying the levels of the mercury in the arm, that height value you need to find out. And that is same, let us take the same formula, that is Pa is equal to, that is rho into G into H. Rho is water density and H is, that is height of the water column, and you need to find out. And this Pa is equal to, that is 1000 into G is, that is around, you take this is 9.81, and this is H1 means 10 plus 15, that is 25 centimeter, 25 centimeter, and this is Pa is equal to 1000 into 9.8 into 25 into 10 to the power minus 2 meter. Minus 2 meter, centimeter is getting converted into meter. Calculate, you are getting Pa. The Pa is equal to around 25 into 10 to the power of 2 Pascal. This is the pressure on A point at one end, and let us take calculate here Pb. What is Pb? Pressure on B point by this column, and that is Pb is equal to same rho 2 GH2, and this is rho 2 is density of this spirit, you already calculated in the previous problem, that is 0.8 into 10 to the power of plus 3 into G is 9.81 and into H2 is 12.5 plus 15, that is 27.5, and after getting calculated Pb becomes, that is 22 into 10 to the power of, this is in terms of meter I am taking, 22 into 10 to the power of 2 Pascal. And here after adding, the diagram becomes like this. The diagram becomes like this, and here mercury becomes falling, and mercury here somewhat it is rising. The mercury is rising because here more the pressure by the water, lesser is pressure by the spirit. This is by water, this is by spirit pressure. In downward direction, water exerting the pressure on the mercury at this point, this is a A point, and downward direction spirit exerting the pressure in downward direction, this is a B point. The pressure exerting on A point is more than the pressure exerting on B point by the spirit. This is the pressure on mercury, this is the pressure on mercury, and here the pressure on mercury I am taken it as a A point, I am taken it as a B point. Here more is the pressure by the water, here lesser is the pressure by the spirit on the mercury. Because of more pressure it is falling down, because of less pressure by the spirit it is rising up. How much it is rising up? This is the level of the mercury, and this H you need to find out. Why it is falling down? Because the pressure exerted on the mercury by the water is more, and the pressure exerted by the spirit on the mercury is less. Lesser is the pressure, more is the pressure, that's why mercury is rising like this and falling here, rising. Then the level of the mercury is not become same. Then there is a difference in the level of the mercury, that is H. That H you need to find out. Here the pressure by the water is more because the density of the water is more as compared with the density of the spirit. That's why the more pressure on the mercury by the water, the less pressure on the mercury by the spirit. That's why here falling down the level of the mercury, and here level of the mercury is rising up. Therefore there has been a difference in the levels of the mercury with how much length, that is H. That H you need to find out. The difference in the level of the mercury means the H value you need to find out. And here therefore that difference can be written as Pa minus Pb is equal to PA minus PB is equal to rho into G into H, and PA is here 25 into 10 to the power of 2 minus PB is 22 into 10 to the power of 2 divided by, take rho here, take G here, and find out H. And if you calculate the H, you are getting the 25 minus 22, that is 3. That is 3 into 10 to the power of 2 divided by, rho is the density of mercury, that is 13.6 relative density he has given, and G is, I am taking it as almost 10, and this is density of mercury, that is 13.6 into 10 to the power of plus 3 is there, you can take plus 3. Density of mercury is 13.6 into 10 to the power plus 3 into G, I am taking almost 10, and this is 25 minus 2 is 3 into 10 to the power 2. After calculating, you are getting that H is equal to 0.0022 meter. You are getting this difference in the levels of the mercury, you are getting H is equal to 0.0022 meter. And here, why the mercury is falling down and why the mercury is rising up here? Because the water has more density, that's why the more pressure exerting by the water A point, that's why the mercury is falling down. By the spirit, the pressure exerting on the mercury is less, that's why it is rising up. In this level, the mercury is rising up, in this level, the mercury is falling down. Therefore, the levels is creating the difference in the height. That height you need to find out, that height becomes 0.0022 meter, and please note down. And go to next question, that is exercise number 11.10.11, mechanical properties of fluids. Read the question first, what he has given. Can Bernoulli equation can be used to describe the flow of water through a rapid in a river, and explain. And what he has given, the question is a theoretical question and not important, just you can need to know the water is flowing in the river and the type of the flow is a rapid, not slow motion, that is a rapid one, fast flow of the water. That can Bernoulli equation be used to describe that flow of the water? He asked the question. In theory depth I have discussed about Bernoulli's equation, and before Bernoulli's equation where we have to apply the condition also I have discussed. What is that one? There are two types of the flow of the fluids. One is a streamline flow or a laminar flow, and the second type is a turbulent flow. What is a streamline flow? The velocity of each and every particle of the fluid is the same at a given point. That flow of the fluid is called as a streamline flow or a laminar flow. And second one is, if the flow of each and every fluid particle is not same at a given point while it is flowing, that flow type we are going to call it as a turbulent flow. And here what he has given, can we apply a Bernoulli equation for the rapid flow of water in the river? It is highly impossible. No, because answer is no, because Bernoulli's equation can only apply, Bernoulli equation can be only applicable to streamline flow, applicable to streamline or laminar flow of fluid, applicable to streamline flow of fluid, streamline flow of fluid. Therefore the flow of water, therefore rapid flow of water in the river, rapid flow of water in the river, flow of water H2O means water in the river. In the river is a turbulent motion. River is a turbulent flow. Is a turbulent. Therefore, the Bernoulli application or the Bernoulli equation is only used to describe which type of the flow of the fluid, that is a laminar flow. Bernoulli equation anna streamline flow of fluid ಗೆ ಮಾತ್ರ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. That motion of the fluid that should be laminar or streamline. Then in order to describe the flow of the streamline, that can be, we are using a Bernoulli equation, but a rapid flow of the water in the river is not a streamline, instead it is a turbulent. That's why Bernoulli equation is not applying in order to explain the flow type of that rapid type of water in the river, because that is a turbulent, and the Bernoulli equation only applicable to streamline and not for rapid flow, because a rapid flow of water in the river is a turbulent. And please note down this also. This is a theoretical question. And go to next question, that is 11.14 exercise, and 11.12 and 11.13 exercise you leave it because that is out of syllabus, and read the question 10.14. In a text experiment on a model aeroplane in a wind tunnel. Wind tunnel means that is the place having a more depth, and at that place the flow of air is more. Getting? This is the tunnel means that is the place where the more flow of the air is there. We are going to call it as a wind tunnel. There has been an experiment is doing in a model, in a test experiment on a model aeroplane. Just one aeroplane is there. That aeroplane is a model one. It means it is made up of a plastic now, and we are testing the experiment in a wind tunnel. The flow speed of air on upper wing and lower wing of the surface is, that is a 70 meter per second and a 63 meter per second respectively he has given. Let us take it as a aeroplane, model aeroplane made up of paper, and these are two wings of the aeroplane, and here this is upper surface of the wing, this is upper surface of the wing, and this is a lower surface of the wing. And in theory I told you always the air flow, the speed of air on the upper surface is more as compared with a lower surface. Whatever it is, the object is moving in the space and it is having the two surfaces, one is the up surface and another one is the down surface. Always while the object is in motion in the space, then the flow speed of air on the upper surface is always more as compared with the flow speed of air in the lower surface, and the same he has given in the question. The flow speed of air on the up surface of the wing is 70 meter per second, and that of the lower surface of the wing is 63 meter per second. And what is the lift on the wing? If the area of the wing is, he has given 2.5 meter square. Both the wings are same in size, and both the areas of the wings are, he has given area is equal to 2.5 meter per meter square. And take density of the air, that is he has given, that is 1.3 kg per meter cube. Whenever the aeroplane is moving in the air, then the air is blowing on upper wing of the surface and lower wing of the surface. He has given both the speeds V1 and V2 respectively. Because of air blow, here more the speed of air and here lesser is the speed of air. This is a wing. Here more the speed of air and here lesser is the speed of air, and lesser is the speed, more the pressure in up, and more the speed of air, lesser is the pressure in down. Downward pressure is less, upward pressure is more. I told you the relation between velocity and pressure. It is the wing surface, the more is the speed of air and lesser is the pressure. And here lesser is the speed of air and more is the pressure in upward. As compared with the downward pressure and upward pressure, the net pressure on the wing is always in upward direction, because as you know very well, less pressure and more pressure, the net direction of the pressure is on the upward direction. That's why the aeroplane is lifting. this lifting of the object in the space because of motion of the fluid particles, we are going to call it as dynamic lift. What do you mean by dynamic lift? I have explained in the theory class by using many examples. Remember once again what do you mean by dynamic lift? What is dynamic lift? It is the lifting of the object in the space by the motion of the fluid particles. That lift we are going to call it as a dynamic lift, and the force responsible for the lifting of the object, that is we are going to call it as a thrust or a normal thrust. A normal force is called as a thrust. And you need to find out what is the lift on the wing. More the speed of the air on the wing, lesser is the speed of the air down the wing. More the speed, lesser is the pressure, lesser is the speed of air, more the pressure. As a result, there has been a lift on the wing in upward direction, lift or thrust. You need to find out that lift or thrust on the wing. Andra a aeroplane the wing the mala upward direction daga lift test ada. Upward surface mala air ಜಾಸ್ತಿ ಸ್ಪೀಡ್ ನಾಗ ಮೂವ್ ಆಗೋದ್ರಿಂದ ಡೌನ್ವರ್ಡ್ ಪ್ರೆಷರ್ ಕಡಿಮೆ ಇರ್ತದ, ಬಿಕಾಸ್ ಲೆಸ್ ಪಾರ್ಟಿಕಲ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇರ್ತಾವ. ಇಲ್ಲಿ ಲೆಸರ್ ಇಸ್ ದ ಸ್ಪೀಡ್ ಆಫ್ ಏರ್ ಪಾರ್ಟಿಕಲ್ ಅಂದ್ರೆ ಇಲ್ಲಿ ಜಾಸ್ತಿ ಪಾರ್ಟಿಕಲ್ ಸರ್ಫೇಸಿಗೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇರ್ತಾವ, ಅದಕ್ಕೆ ಜಾಸ್ತಿ ಪ್ರೆಷರ್ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ದಾಗ ಇರ್ತದ. ಅಪ್ವರ್ಡ್ ಜಾಸ್ತಿ ಅದ, ಡೌನ್ವರ್ಡ್ ಕಡಿಮೆ ಅದ ಅಂದ್ರೆ ಏರೋಪ್ಲೇನ್ ಲಿಫ್ಟ್ ಆಗ್ತದ. ಆ ಲಿಫ್ಟನ್ನು ಎಷ್ಟು ಅಪ್ಲೈ ಆಗ್ತದ ಅಂದ್ರೆ ಅಪ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ದಾಗ ನೆಟ್ ಫೋರ್ಸ್ ಎಷ್ಟು ಆ್ಯಕ್ಟ್ ಆಗ್ತದ ಅಂದ್ರೆ ಲಿಫ್ಟ್ ಅಂತಾರೆ. ಆ ಲಿಫ್ಟನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿರಿ, ಥ್ರಸ್ಟನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿರಿ ಅಂತ ಕೇಳಿದಾರೆ. ಬಿಫೋರ್ ಗೋಯಿಂಗ್ ಟು ದಟ್ ಒನ್, ಬೈ ಯೂಸಿಂಗ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ಬರ್ನೌಲಿ ಇಕ್ವೇಷನ್, apply Bernoulli equation, that is on the upper wing as well as on the downward surface of the wing. Let us take the P1, apply Bernoulli equation. Apply Bernoulli equation. Bernoulli is equation that is for upper surface. For upper surface of the wing, for upper surface of wing, that is, remember Bernoulli equation once again, theoretical formula, that is P1 plus 1 by 2 rho V1 square plus that is rho GH, and here, and this is equal to equation 1, and apply Bernoulli equation to downward surface or lower wing, that is P1 P2 plus 1 by 2 rho V2 square plus rho GH, and let us take it as a equation number 1. Equate equation 1 and 1, that is P1 plus 1 by 2 rho V1 square plus rho GH1, this is S2, this is equal to P2 plus 1 by 2 rho V2 square plus rho GH2. And upper surface and lower surface almost from the ground surface height is same. H1 and H2 is always same, almost same, because upper surface from the ground height is a H1 and lower surface is a H2 from the ground, that is H2. Almost H1 and H2 from the ground surface is same, therefore these two are getting cancelled because H1 and H2 both are almost same from the ground surface. And what is remaining? P1 plus 1 by 2 rho V1 square is equal to P2 plus 1 by 2 rho V2 square. Here H1 and H2 both are same, therefore rho G H1 and rho G H2, because H1 as a H, H2 as a H, both the terms are getting cancelled because upper surface from the ground is H1, lower surface from the ground is H2. Almost H1 and H2 from the ground surface is almost same, that's why take H1 as a H, let us take H2 as a H, then rho GH and rho GH getting cancelled and no more term of rho GH. And here P1 as it is, take P2 this side and plus 1 by 2 rho as it is, and take this one this side, V1 square minus V2 square. P1 as it is, take P2 this side, it is minus 1 by 2 rho V1 square, and take 1 by 2 rho V2 square in this side, that is 1 by 2, rho is a common, then V1 square minus V2 square. Therefore, we know that pressure is equal to force per unit area, then force is equal to P into A, and this P1 minus F is equal to P means P1 minus P2, difference of the pressure, and this A as it is, and substitute all the values. F is equal to P1 minus P2 in the sense you can substitute this one. P1 minus P2 is nothing but that is 1 by 2 rho as it is, V1 square minus V2 square, and this A as it is, and substitute all the values. 1 by 2 as it is into rho means he has given for air density 1.3 he has given, and into V1 is he has given 70, V1 square is there, 70 into 70, that is a 70 square, minus V2 is a 63 means V2 square is there, 63 into 63, that is a 63 whole square, and into A nothing but he has given that is 2.5. He has given 2.5 meter square, and substitute all the value. F you are getting 1.51 into 10 to the power of 3 Newton. 1.51 into 10 to the power of 3 Newton. Whenever the aeroplane is lifting, downward force and upward force, and the upward is more than downward force, then the downward minus upward, then whatever it is the answer you are getting, upward net force is equal to 1.51 into 10 to the power of 3 Newton. First Bernoulli equation apply for upper surface, that is this one, and for lower surface, that is this one, and upper surface and lower surface from the ground is almost same. Therefore, take it as H, this as H, this as H, and this as H, then equate these two. This is H and this is H, both the terms are same, and this term getting cancelled, remaining P1 plus 1 by 2 rho V1 square, P2 plus 1 by 2 rho V2 square, and P1 minus P2, it means that P1 as it is, take here, it is a minus, plus 1 by 2 rho V1 square as it is, take this whole term this side, that is P1 by 2 rho V2 square, and 1 by 2 rho is a common, V1 square minus V2 square, V1 is nothing but this much, V2 is nothing but this much, and substitute all the value, and pressure is equal to force per unit area, lift or thrust is equal to pressure into A, pressure is equal to difference of pressure, downward pressure minus upward pressure, downward pressure is a P2, upward pressure is a P1, then difference of the pressure is, this pressure is equal to P1 minus P2 into A, P1 minus P2 is nothing but substitute this equation here, and V1 is this much and make it square, V2 is this much, make it square, area is this much, substitute there and find out the answer. We are getting the upward lift or a thrust on the wing is 1.51 into 10 to the power of 3 Newton, and please note down